Welcome to this video. We will talk about substructure in a network. So in the past, we examined either the node's individual positions within the network or the aggregate network structure. Indeed, one of the value of using networks is basically to uncover hidden substructures within the network. And those hidden substructures have to do with the node connectivities with each other. Indeed, we looked at one example substructure, which is the cliques within the network. Let's re-examine this example here. I'm going to load the Florentine network here. And as you can see here, just looking at this network, one can see that there are some tightly connected families, such as, for instance, this clique in here, this clique in here, this clique in here. When we look at this network, just examining it, we can actually distinguish in between different parts of the network. So one can claim that this part is highly connected with each other and we have a densely connected part here. A clique is a set of nodes that are all connected with each other. So a clique of two nodes means that the two nodes are connected to each other, which is not a very interesting clique. It becomes interesting when we have more than two nodes. For instance, if we have a clique of three nodes, for instance, this clique here, it means those three nodes are all connected with each other, meaning the Medici connects to a Ridolfi. The Ridolfi is connected to the Tromboni, as well as the Medici being connected to the Tromboni family, right? So that's a clique here. Now, a clique as a substructure is very restrictive. We need all nodes to be tightly connected together. If you take a look at these four nodes, for instance, these four families, it's not a clique because it's missing this link between the Bicchieri and the Castellani family. That said, we still recognize this part of the network as, a densely connected part. So when we talk about the substructure within the network, there are more advanced algorithms than algorithms uncovering cliques. And those algorithms are called community detection. A community is generally defined as a subset of the network which is densely connected, but not as densely connected as with other parts of the network. And there are many community detection algorithms. We're going just to try one of them called greedy modularity community algorithm. I'm just going to import the module, the package community, which contains multiple of these algorithms, and we're going to apply it on the network here. Once we apply it, you can see that the network here, I'm going actually to plot the network again so we can see it side by side with the output of the algorithm. You can see that this algorithm actually uncovered this densely connected part of the network, the Castellani, Pruzzi, Strozzi, excuse my Italian here, part of the network, right? It's also included the Barbadori as part of this densely connected part. It also says, so we basically have three communities in this network, this community, and this community. Now Medici happens to be in this community, which contains also this family, right? But then we have the last community, which is this one containing the Albizzi, Ginori, Guadagni, and Lamberci. So basically those four nodes here. So you can think about these four nodes here as a community. There's not connected much with the rest of the network, but then you've got a big community here, which is, centered around the Medici. And then we have the Perucci community here. Once we do community detection, we need to look at these communities to figure out what they mean. So absent any other kind of information about the network or the processes that led to this network forming, this algorithm is not very useful. It's very useful when we know, for instance, what kind of relationships were entertained between these families. So it's useful, for instance, when we have more qualitative information about the network in order to interpret what these communities mean or what they reflect. Community detection is an example of a clustering algorithm. Here we've got a bunch of groups, a bunch of clusters that were created without us providing any extra information apart from the network structure itself. We're going to look at further examples of using community detection in order to understand the hidden structure of data in the next exercise.